Hello guys, welcome to the channel. I hope you all are fine and doing great. So today we are going to discuss this lead code daily problem, all element and two binary search tree. So first of all, we are given two binary search tree. So the basic property of a binary search tree that the leaf node value is always less than its the value of its root node, and the value of root node is always less than the value of its right node. I am telling you this because we will use this property in solving this problem. So we can say in our binary search tree our integers are in ascending order from leaf, root, right. Okay, first of all the smallest number is left node, then root node, then its right node. Okay, similarly here leaf is smaller than root, root is smaller than right. Okay, so guys, what we have to do, we have to find out a array that contain all the values of these two, can I yes, of these two binary search tree, but in ascending order, means in sorting order. So a simple method to do it is to do in order traversal of both the trees in a vector, and sort that vector and return it. Okay, but it is n log n property, it is n log n approach. It is very easy approach, so you can also do it, but now I am telling you on approach by using stack. Okay, on approach by using stack. Here also you can see we are given two binary search tree and the return is this. Okay, so guys, now on to the solution. So this is our solution. So guys, this is function given to us. So first of all, what we do, we will take a stack which will store the address of my particular node, and I take two stack s1 and s2 of that type. Then I will took a vector int that will store my the answer of my values, like my this vector is represented by my vector answer. Okay, this is the final vector that I have to return. Then I will took a simple tree node just to point out whether which node I have to check it, so I don't need to declare it all time. That's why I declare it in function. Okay, so guys, now what we do, we call a function solve and put out the value of r2. Like what we do, as I already told you, a root node always have value greater than left node. So the smallest value in a for a particular node can be its leaf node, sorry, left node. Okay, like if there is a tree like this, there are okay, it is like this is a very big tree, suppose it, or there are some right node is L1. So the minimum value of this node can be in this. For this the minimum value can be this, and for this the value of node less than this is this. So this is the leftest node. Okay, now the second smallest value is of this node, and the third smallest value is of this node. Okay, so now wait a minute. Okay, I don't know what happens. Okay, so now I am at this node, and this node also have some left node. So when we are doing this node, so before doing this particular node, we have to complete the working on this node. I'm changing the color. So when I am on this node, so before this node, because this and this node contain values smaller than this node, because these two are on the left side of this node, so we will iterate, we will do function with this and with this node before our this node. Okay, I can delete it, so I am explaining you. So for I am passing the address of the stack because I want to modify my stack in each iteration. I pass out my tree node x. You can see here I named it as x. Okay, so while x mean while x is not is equal to null ptr, means x contains some address. What I will do, I will push s, then I will shift x to x left. Like initially my x is here, then I will push this, then because there is nothing to push, so my while loop will complete. Okay, and I will return here. So my s1, initially my s1 will contain 1 on top, 2 on 2 on second top. Okay, like now my stack is like as you also know, our this is our s1, and first of all it will contain 2. First of change the color. First of all it will contain 2. For, yes, now first of all it is contain 2, then it is contain 1, this one. Okay, and my stack, okay, no problem, I just do my s2 will contain my root node, so 1 1 and then 0 and then 0. So okay, so initially my s1 and s2 will look like this. Okay, then I am doing a while loop, and in a while loop you can see my while loop and here, and I just return answer. So in this while loop I am doing my function, main function is this while loop. So while what I am checking, while I have some element in my first stack s1 or in my second stack s2, I will run this while loop. Okay, I took a variable a just represent on which stack I am doing operation. Like if I am doing operation on stack second, then my a is equal to second. Else while if I am doing operation on sn, my a is equal to 1. You can see here I am doing operation on second and my a is equal to 2. I am doing operation on 1 and my a is equal to 1. Okay, so but and I used my tree node x here. So if my first stack is empty, then it's necessary for me to do operation on second stack. So what I do, I took the minimum value of my stack 2, because on top it always contain the minimum value, as I already told you, leaf node minimum, then root, then right. Okay, and before right we will traverse its left node also. Okay, so and I pop up the that node from our stack 2. Okay, so my a is equal to 2, my x contain the top node, and I pop out it. Okay, and if my stack 2 is empty, then what I do, my a is equal to 1, and I took the top value of my stack 1 and I pop down that node from my stack 1. Okay, then if my stack 1 is not empty, my stack 2 is also not empty, so it means both of them contain some value. So what I do, I will check if my s1 top value is greater than my s2 top value, then it means my s2 top value is less than my s1 top value, and it will come in my answer first. So okay, so I will pop out this, I will pop out the minimum value. S2 pop contain minimum value, so I will pop out minimum 1. Okay, x will contain the root node, sorry, the node on the top of s2. I pop out this value and a is equal to 2. Else while it means my stack first dot top contain value equal to or less than stack 2. Okay, so I will pop out this value and my a is equal to 1. What I do, first of all I will add that value in my answer vector. In my answer vector I just push that value. Else what I will do, if my a is equal to 1, then I will call function solve again for s1 and x right. Like if I am in this node at 2, and it means I complete with my 1 and I complete with my 2 also, because I had push the value of that node. So now what I have to do, I have to do functional with this. Okay, so that's why I am right here x right. Okay, else while if I am doing operation, if my a is not equal to 1, then it means my a is equal to 2, so I will do function on my stack second with x right. Okay, so first of all what I will do, I will push back x right, because this x is represent the x to right, the current node I am working, the right node of it. Okay, then I will again pop the left node of it, because I told you because I have this node, this is some tree, and this is some tree like this, and I completed with this node, then I will do working on this node, and once I will complete working of his node, then I will come at this node. Okay, I will come at this node, and if this node also contains some left node, if it contains, then the, because we have to do the minimum value, so the value of this node, well, the value of this node is less than this node. Okay, so what I can say, sorry, it's not receiver on. Okay, so I am at this node, I complete the working of this node. I will now see what can I do with my right node, and for before accessing this node I will access its left node. Okay, so as you can see, I will push back my right node and push back its left node after that. Okay, so you can see I submit it. You can see I can show you my accepted code. So you can see this is my accepted code, accepted. Okay, so you can see this is my same solve function that I explain you. This is my same code to stack answer, everything is same. Okay, so guys, if you don't understand it, then just try to dry run it. Okay, because it is a very simple approach. You can do it by n log n by sorting vector, but this is ON approach. This is very modified approach. This is long but a modified approach and explainable also. So guys, I hope you like it. So please subscribe the channel and like the video. You can check out my channel for more amazing LeetCode and GFG videos, and I will also start posting code force and code sub solution also. So if you have any doubt, then just comment it and I will try to explain it. So guys, thank you for watching this, guys. Meet you next time.